All right, what we got to learn about today is called skew. Oh, something skewed. What's that mean? Turned, kind of crooked, something like that, right? All right, so with statistics, kind of similar. What the skew shows is how asymmetrical your data is. So if you have something that's symmetrical, it's the same on both sides. Asymmetrical is the opposite of that. So if we want to find skew or figure out how skewed our data is, we want to compare the mean and the median. All right, so if we have zero skew, what that means is your data is going to look like a nice curve like that. If I draw a line down the middle, it's basically the same on both sides. All right. What that means is our mean and median are the same, or at least, very close to the same. They might be off like a little bit, but the closer they are to the same, the less skew we have. All right. Make sense so far? Right skew. This is an example of right skew. Where this gets confusing is which side is the bump going to? The bump's going to the left. The reason it's called right skew is you're looking for basically like the tail of your data where it's going longer. And you can see on the right side how it's going longer out there, right? That's why it's right skew. When we have right skew, what we have is the mean is greater than the median. Write that down on your board so you got that. You just put right and then mean greater than median. So, that's kind of one of those, if you have a mean of 10 and the median is 9.9, yeah, that's going to have like a little bit of a right skew, but that's not like a huge amount. Those are pretty close. But if you have, like a mean of 20 and a median of 9.9, that's going to make your skew a little bit bigger. All right, everybody got it? Left skew then, just going the other way. This time, if we slice it down the middle of our big hump there, we got more of that tail to the left. And what that means is our mean is less than the median. So the main comparison when we're looking for our skew is comparing the mean and the median. Since we're comparing mean and median, probably using L1 and putting them in and doing the one variable stats on the yellow calculator is going to be the easiest way. All right, so we got data here. So first thing we want to do, we're looking for which statement's true. All the statements are about skew. So put them into L1, and we want to find the mean and the median. Who can give me the mean? Emmy? Just because of my space, I'm going to put that as 52.9. All right, what about the median? 49.5 is correct. All right, so everybody good with those? All right, so that means our mean is greater than our median, okay? Which way is that skewed then? Right, so we're going to have right skew. That means we automatically can eliminate the two that say left. All right, so now we're trying to figure out which one makes it that way. Y'all, the mean has to be higher, right? What's going to make the mean higher, a high number or a low number? High number. So our higher number is going to be what's affecting the skew and making it go to the right. That makes sense? Not horrible, just kind of odd to it. All right, so this one. We got 7 people there. All of them got like 100-something baseball cards, okay? It says we're going to take an 8th person that has 842 baseball cards. Y'all, what's that going to do to the mean? Go up, probably a lot, right? Because that's way above. What's that going to do to the median? It's going to go up, but is it going to go up a lot? No, because the median's still going to be in between two of those numbers. So the median's going to stay about the same where the mean's going to increase. So that means the mean is going to be a lot higher, right? So that means, again, we're going to have what kind of skew? Right. Everybody kind of follow? So if I'll even show, if I put them in order, I got 121, 130, 142, 145, 145, 150, and 163. So my median right now is right there. All right, that's the middle number. If I add the 842, my new median is in between those two numbers. Well, look, that's between 145 and 145, so the median didn't even change at all. Like, even if it ended up between the 145 and the 150, it was only changed like a little bit. But that's really going to change your mean. All right, y'all try that one. Let's see what we get. We get a bunch of, what are these, employees, 9 employees, and then we're adding a 10th employee. Nope. C is correct. All right, so when you look at it, what we're looking for is, first we want to look at our mean and our median before we add that 28. So if we look at our one variable stats, our mean is about 53.2 and our median is about 52. They're kind of close together, mean's higher though. All right, so then you go with your stat, put the 28 back in, or put the 28 in, and you're going to get one variable stats again. This time, the mean is 50.7, and the median is 51. They got closer together, didn't they? So the closer they are together, the more symmetrical your data is. That is why that one would be C. What a low number does is a low number shifts the skew to the left, a high number shifts the skew to the right. The reason this low number made it more symmetrical though is because it was already a little bit to the right. That makes sense? So just kind of comparing them each time makes a little bit of a difference there.